Hi, so in this video we're going to go over more about the unit circle and the coordinates. So here's a picture of the unit circle, and as you can see it has all the different angles and the coordinates on the unit circle for them. And remember, the coordinates are cosine of theta, comma sine of theta. So you can use the unit circle to actually know the cosine and sine of different angles. So here's a unit circle here, and let's start with an example. So here's an angle of 30 degrees. So here's an angle theta, and it's 30 degrees, as you can see right there. It says 30 degrees. And here it says the coordinates of the point on the unit circle. Remember, the unit circle has radius 1. So it makes a triangle here. And here's the coordinates of the point where it touches the edge of the circle. And the coordinates are square root of 3 over 2 comma 1/2. But remember, we learned in the last video that the coordinates are cosine of theta comma sine of theta. So in this example, theta is 30 degrees. So cosine of 30 degrees is square root of 3 over 2 right there. And sine of 30 degrees is 1/2. So this tells you the sine and cosine of 30 degrees. Similarly, over here at pi over 4 degrees or 45 degrees, so pi over 4 radians or 45 degrees, the coordinates where it touches the edge of the circle are square root of 2 over 2 comma square root of 2 over 2. So we can say that the cosine of 45 is square root of 2 over 2, and the sine of 45 degrees is square root of 2 over 2. Okay? Once again, 90 degrees. The coordinates are 0, 1. So we can say that cosine of 90 degrees equals 1, or pi over 2 radians. Equals 0. And then sine of 90 degrees equals 1. Remember, 90 degrees is pi over 2 radians. Okay? We can even do that for obtuse angles, like 2 pi over 3 radians, or 120 degrees. We can see that the cosine of 120 degrees is negative 1/2, and the sine of 120 degrees is square root of 3 over 2. And it's interesting because here the coordinates, see how the x coordinate here is negative? That's because it's a reflection of this point. It's just on the other side of the y-axis, so you just make the x coordinate negative. And here the y coordinate becomes negative because you're flipping the point across the x-axis. Okay? So this is how we can use, this is why the unit circle is really important in trigonometry, because the x and y coordinates of the points are just the sine and cosine of theta. But in this video, we're also going to go over about what the tangent of theta is. So let's forget about these coordinates for a minute and call this x comma y. Then we know that this length is 1, this length is x, this length is y of this right triangle. This is theta. What's the tangent of theta? Well, that would be opposite, which is y, divided by x. So, tangent of theta is the y coordinate divided by the x coordinate. But, now, let's find the slope of this line. So, this point is x comma y, and this point is 0, 0. So we have 2 points, and we can find the slope, which would be y minus 0, it's the change in y, over x minus 0. Just change in x. But that equals y over x. And y over x is just the tangent of theta. So now what we found is that the tangent of theta is the slope of this line when it touches the edge of the circle. So here, the tangent of theta would be the slope of this line. At 150 degrees, the tangent of theta would be the slope of this line. At 210 degrees, the tangent of theta would be the slope of this radius. So now we know what tangent of theta is. It's y over x. Okay, so let's write down what we've just learned. We know that tangent of theta equals y over x, or the slope. We know that cosine of theta equals x. So here's a point x comma y. And we know that sine of theta is equal to y. So that's what the unit circle is good for. So I hope you like this video. We're going to learn more about trigonometry in the next video. Until then, see you next time.